Okay. Again, this is a couple pages long. Be careful there. This should be pretty easy. We all should know that velocity is the derivative of position and acceleration is the derivative of velocity, or the second derivative of position. We're going to graph all three of those on separate graphs. Now listen to my words here. You're never in your life going to turn in an unlabeled graph to anybody. You're going to graph, label your axes, and include units on your labels. So we're drawing three separate graphs here. And honestly, you should easily be able to draw them all. Just rough sketches. They don't have to be perfect. Like that's a parabola. You don't have to find like the t-intercepts and all that. Okay, now we're going backwards. We've got some function. We want to sketch his velocity graph. So we have to be able to think about, what does the derivative tell us? A derivative tells us slopes of tangent lines. So look in this region right here, from 0 to 5, 4, or from negative infinity up to 4. My function is increasing that whole time. If I'm going from left to right, my function's increasing. That means my derivative is going to be positive. From 4 to, what is that, 7, 8? I think 8. My function's decreasing, so my derivative will be negative. And then from 8 to infinity, it will be positive. So I need something that goes positive, negative, positive. Another way to think about these is when you're graphing a polynomial, derivatives always have one hump less than the original function. You lose a hump every time you take a derivative. This is a cubic function. It has two humps. So his derivative is going to be a quadratic. He's only going to have one hump or valley. Now we're going backwards. So this is the one, like I remember when I took this class, I even struggled with these. Because you got to think backwards. We're looking at the derivative. We want to graph the original. So what we just said, when you're taking derivatives, you lose humps. When you're going the other way, you gain humps and valleys. This is a quadratic. He is the derivative of a cubic. We're going to have a third degree polynomial as our position function. Okay. Any place this guy is positive. I don't care if he's going up or down. I don't care about increasing or decreasing here. I care about positive or negative. So from -1 to 4, the derivative is positive. My original function must have been increasing from -1 to 4. And all these regions here where the derivative is negative, below the axis, negative, my other function must have been decreasing. So we're going to be going decreasing, increasing, decreasing. And technically, there are an infinite number of functions that have this guy as the derivative. We want the one that passes through the point 0, 0. So that's where I would start and work front and back from that.